Hi, everybody. Today, we're going to cover place value from millions to millionths. We're going to start with this number here. And just like always, we're going to look at our place value starting from the right and working our way to the left. Ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions. But that's not all. We also need to take into account how we read our numbers. It's important to notice that we organize our numbers starting from the right and working our way left into periods. We count off 3 digits, 1, 2, 3, and we separate it with a comma. We call this a period. I think it's funny that we call the periods, but sort them with commas. And there's our final period. You can see in this number we have 3 periods. Let's see what Mrs. Lynch has to say about that. Okay. We read our number using those periods. The 7 is in the period the furthest to the left. We're going to start reading our number there. We have 7 million. We read off the number of the smallest place value in each period after saying the number. So really, we never have to worry about reading a number any larger than 3 places. Here's what I mean. 7,345,678. There, no need to ever worry about how to read larger numbers because it follows the same rule. All right, but now we need to think about expanded form, and we're going to separate it just like we always do. We're going to take each digit and show us what place value it's in by putting in our zeros. So we have 7 million plus 300,000 plus 40,000 plus 5,000 plus 600 plus 70 plus 8. You can see that here stacked, or we can even write it out with exponential notation. Let's see what I mean. So here we have it again, and you'll see that we start off with this 7 times 10 to the power of 6. Well, 6 is an exponent that tells us how many times we need to multiply the base number, in this case, a 10. Here it is written out. We have 10 to the power of 6 is 10 times 10 times 10 times 10 times 10 times 10. We'll do it for each of the others. 10 to the 5th, 10 to the 4th, 10 to the 3rd, 10 to the 2nd, 10 to the power of 1. And finally, I'm going to put the 8 there just so I don't lose him. All right, but how do we solve it? Well, 10 to the power of 6 is just 10 times 10 times 10 times 10 times 10 times 10. And when we multiply it out, we get 1 million. And if we multiply 7 by a million, we get 7 million. Let's see what happens for everybody else. 7,300,000, 40,000, 5,670, and 8. And that's how we get our expanded form for whole numbers. But what happens when it's time for decimals? Well, I'm going to use this place value chart to help us out today. And what I always like to think of is a broken mirror or a fold on a piece of paper, starting with getting rid of the ones and the decimal point. And you'll see what I mean if you just follow along for a minute. If you look at the way we always organize our numbers over here, you'll notice that we do the exact same thing over here, just in the opposite direction. It's almost like a folded piece of paper. So if we have the tens here, we have the tenths over here. You'll notice they're even the same place value names, just with the TH put in there. Let's keep going. Hundreds, hundredths, thousands, thousandths, 10,000, 10,000ths, 100,000s, 100,000ths, millions, and millionths. What do you think comes next? If we have the 10 millions over here, what are we going to have all the way over here? I hope you're thinking about it. It would be 10 millionths. Great job. Okay, but we still have to worry about how these are lined up when we have a real number in front of us. Well, instead of starting way over here like we do for whole numbers, we're actually going to start over here closest to our decimal point. It'll help us keep track of what number we're looking at. So 7 is in the tenths place, then the hundredths, then the thousandths, then the 10,000ths, then the 6,000ths, then the 7 millionths, than the 8 10 millionths. Don't forget those THs. All right. I think Mrs. Lynch wants us to pay attention to the TH also. Look at that. Can you guess? 10 millionths. All right. Reading decimals. There really is a way, and it's not that hard. It all starts with ignoring the decimal and reading the number just as if it's any other number we've ever read. You start by looking at the number the furthest to the left, and then you just read it along. And it helps if you can remember where to put those commas, because then you just say it just like that, and then finally announce the value of the decimal in the smallest place value. Watch. Let's see. So I'm going to cover up the 0 and the decimal point. Then I'm going to count out my periods so that I can read my number is 7,345,678. No different than the one we did before. Except now we're going to look and see what place value the 8 is in. It's not the tenths, it's not the hundredths, or the thousandths, or the 10,000ths, or the 100,000ths. It's not even the millionths. We finally find it over here in the 10 millionths place. Now we need to put it all together. So we have the 8 in the 10 millionths place, and we have our number 7,345,678. Now we just have to put it all together. We start with the 0 and we move on to the 7,345,678, and then we announce the value of the digit in the smallest place value, 10 millionths. We put it all together and we get 0 and 7,345,678, 10 millionths. Wow, is that a mouthful? Okay. But we can't stop there. We still have to look at expanded form. So, just like when we use expanded form for whole numbers, we're going to use expanded form for our decimals. Except instead of the zeros being to the right of the number we're talking about, we're actually going to put the zeros in between the digit that gives us our value and the decimal point. Here's what I mean. We'll start here with 7 tenths, and then we have 3 hundredths. We use this 0 right here so that 3 could sit where it needs to be. And we have 4 thousandths, 5 10,000ths, 6 100,000ths, 7 millionths, and 8 10 millionths. And just like before, we can stack it using zeros to line everything up, or we can stack it without those zeros, but don't forget to keep those decimal points lined up. Or we can use something similar to exponential notation. Let's take a look. So we have the 8 up here in the 10 millionths place, and we can write that out as 8 times 1 over 10 million, which gives us 8 10 millionths. We can do the same for 7, and you'll see that there's one less 0, and we just keep going on from there. Okay.